We talked about how ionic compounds has cations and anions, right? We have those ionic bonds going on. So remember, ionic compounds are always going to contain a positive and negative ion, cation and anion. All right, it's always going to have those. If you don't have those, it's not an ionic compound. Okay. Now, I'm actually about to show you guys a couple different things with this ionic compound. So here's the thing I want you guys to pay attention to. If you understand this now, this will help you later. That's all I can say now. Okay, so you can be able to name compounds without this technique, but if you understand this now, this will help you out later. Okay, so the sum of charges of a positive ion must equal the sum of the negative ion. Okay, let me read that one more time. One more time, okay? Let me read that one more time. The sum of the charges of a positive ion must equal the sum of the negative ion. So your positive ion will be equal to your negative ion as far as with the charges. When this is happening, we have a neutral compound. Okay? We have a neutral compound when this occurs. All right, just remember that. This will help you later on if you understand that. Now, let's talk about writing a formula for the ionic compound between calcium and chlorine. All right, so I'm showing you guys a lot of information right now because when we go to actually doing reactions, this is going to help you guys out a lot. Okay, this is going to help you guys out a lot later on. So let's talk about the very first ionic compound. In this case, calcium chloride, right? I'm not going to show you guys the naming yet. I just want you guys to focus on the formula right now before we get there. So this is called calcium chloride, all right? Naming it is easy. But when we're putting the formula together, that's the key part. That's something that I always see people getting a little confused on. So calcium chloride, all right? So you know the name of it. Cool. Bam, you know it. We'll get to how we name it in a little bit, but I want you guys to really understand as far as how do we even get to CaCl2, right? Where is this Cl2 even coming from? Well, this is because of those charges. The charges are key. So, right, calcium has a charge of +2. How do we know it has a charge of +2, Dr. J? It's on the periodic table. Okay, so when I say that the periodic table will be your biggest friend this semester, it's going to be your biggest friend this semester, okay? Calcium is a +2. Chlorine is a -1. Okay, so here's the thing that I was mentioning, right? That we're going to cover this now more in detail with those families. Remember how I said you want to know those family groups? Now is the time to know those family groups. Okay, those main group elements. Okay, so calcium has a charge of +2. And there's one calcium here, right, in this calcium chloride. We have a +2 charge here for that one calcium. For a neutral compound, which this is here, this is a neutral compound. How do we know it's a neutral compound, Dr. J? We don't have a charge over here. No charge at the very top, right? No charge. So it's neutral. So it's because this is a neutral compound, the sum of your charges of a positive ion must equal the sum of your negative ions. So in this case, I need to make sure that my +2 will be equal to a -2 over here. A cation is a +2, and our anion is a -1. Now, how do we know, right, that chlorine is a -1 charge? The periodic table. Okay, so right now, let's talk about those family groups. Alkaline earth metals, right? We talked about how alkaline earth metals all have the same types of property. Okay? Right? They're fairly reactive metals. Another thing that they have in common is they all have a positive 2 charge. We'll get to the reason why later on, but for now I just want you guys to start memorizing, right? Alkaline earth metals have a positive 2 charge. So in this case, calcium has a positive 2 charge. Halogens with chlorine, right? We talked about how halogens are very reactive gases. Guess what else they have in common? They have a charge, right, of -1. Right, so all halogens will have this charge of -1. So when we look at calcium chloride, calcium has a +2. Chlorine is a -1. So once again, I just said that if it's a neutral compound, which this is, the sum of the charges of the positive ion must equal to the sum of the negative ion. So right now, right, I got a +2 and a -1. Well, I need 2 -1s to get me to my neutral compound. So my calcium, right, it's going to be a +2, and my chlorine is a -1, but I need 2 chlorines, right, for every 1 calcium. And when we see this occur, right, we have an overall charge of 0. And now we know it's neutral, okay?